Okay, in this slide, I would like to explain about what is data structure, okay, and what is algorithm, and then why do we need to consider data structure and algorithm. In this case, I just make it as DSA. Okay, so it is good to make a short, and I will just explain a brief introduction about how to install the Python. I guess by now you already have the program. But let's see, if you still have problems, we can solve it today. First, what is data structure? So there are some data structure that you will learn in one semester. I think you know about array. Array is one of the popular data structure, and I think it is not difficult to understand. The other data structure we will learn about linked list, and then we will learn about stack, and we will learn about queue. So what is data structure? The data structure is method of organizing data in your computer. It means when you want to save your data, there should be a structure, there should be a way, there should be a method. For example, I have this map, G2. This is a simple one. Let's suppose you can see the arrow. It means from house, I can go to store, and from store, I can go to house, because there is no direction. Yeah. So we can have two directions. But because we have arrow, it is one direction. It means I can go from house to police office, but I cannot go back from police office to house. So if I want to go back from police office to house, it means I need to go around school and then go to intersection and then go back. Now, if I have this problem, how can I save my data in the computer? There is one way. So I can save two locations at the same time. I can save house and store. I can save again store and house. So this shows that there is a direction from house to store. It shows that there is a direction from store to house. Store to police office. House to police office. Police office to school. School to police office. House to intersection. Intersection to house. Intersection to school, and school to intersection. Okay. Is it a good data structure? Maybe to understand. But there is another way to save data. I put the origin, or I make one location, for example, house. And then I can set the destination at the same time. So from house, I can go to store, police office, and inspection. From store, I can go to house and police office. From police office, I can go to school. From intersection, I can go to house and school. From school, I can go to police office and intersection. Which one is better? Yeah. In the case of data structure, I think both of them are okay. But later on, when we want to apply some algorithm, it is different. Okay. So, what does it mean by algorithm? There are some algorithms that we will learn during one semester. We will learn about sorting. Okay. There are some algorithms like bubble sort, merge sort, quick sort. And then we will learn about searching. So we are going to search some data. We have the linear search, binary search, and then we will learn about recursion and dynamic programming and etc. Okay, so it depends on the time. We will check some of the important algorithms. So what does it mean by algorithm? The algorithm means operation on different data structures. So if I have the data like the one that I mentioned, there should be an algorithm for data structure 1. If I have the data structure 2, then I need to have an algorithm for the data structure 2. And for this one, we need to analyze. It means I need to know whether the algorithm runs properly, good enough, efficient. Some algorithms take many time. Some algorithms take very short time. So we need to understand how we can use this algorithm. For example, if I have this map again, now find places you can go from. From each of the place, find all the paths. It means from house, I need to check where is the destination that I can reach. Okay, from house, I can go to store, I can go to intersection, I can go to police office. And let's say I want to put the destination from house, I want to go to school. Then from each place, find all paths. It means from each place, after I know the house, and then I know the house can go to store. So next I need to check from store. Is it possible to go to police office? Okay, yes. From police office, is it possible to go to school? Okay, yes. Then this is one path from house to school. We need to calculate the distance to the current place. So if I want to go from house to school, then I need to check from house to store. How big is the distance? From store to police office, how big is the distance? From police office to school, how big is the distance? Then I know the distance or the total distance. If I take this path, I can have another alternative. Repeat this process until you reach the school. So you can go from house to school via police office. And then again, you can calculate the total distance. You can go from house to school via intersection. And again, you can calculate the distance. So, and then you can compare. Which one is the least distance? Or which one is the path with minimum cost? Which path is more efficient? Okay. So, that is the meaning by algorithm. And some algorithm may give you the shortest path. You want to go from Hong Kong to Seoul. Of course, you want to get to Seoul, the best bus. So you want to go to Seoul by bus. Which bus is the best? So let's go back to the data. In the data wise, how can you calculate the distance? So if I want to go from house to school, then I need to check the data one by one. Okay, from house to store. Okay, I can find this one. Then next, I need to check from store to police office. If I go from store to house, then it is detour, or we return back to the home page. It means I cannot choose this one. And then I check this one, store, police office. Okay, and then house, police office. So this might be next because the last node is police office. We need to check again police office to school. Okay, so it means I can check the sequence only 3 times from house to get to the school based on this data structure. Okay. How about if I use the second data structure? In the second data structure, I want to go from house and then I can select which one is the best node from house to store, or from house to police office, or from house to intersection. If I know the best one, then I can select. Let's say house to store is the best distance or is the least distance. Then I can just choose store. From store, I can select which one is the least distance to house. Of course, this is not the option. From store to police office, this is the only option. So we can go to the next is the police office. And the police office has only one destination, which is food. Now, which algorithm should I? Yeah, by just looking at this step, yeah, it is difficult because the data is too small. When the data is big, then there is a threat. This data is, the data structure is easy to understand, but it may take a long time because you need to figure out all the options. This data structure is better because once you know the origin, you just check only the alternative from the existing destination. So you don't need to search all the data. Okay. So that's the introduction. Why we need to consider the structure that we can learn in one semester. Now the question is, why do we need to consider DSA, the data structure and analysis, or in this class we call it the data structure algorithm. So when the data is big, at the example, we have only 5 locations. But in Korea, how many locations do you have? So you have a lot of people, you have a lot of nodes, you have a lot of intersections. Then we need to deal with the big data. There are 6 V of big data. So 3V is the most popular one: volume, variety, and velocity. Volume. Volume means the amount of data from myriad sources. So if you have database, then you can see how big is the data. Let's say you have Microsoft Excel. If the data size is 1 GB, if the data size is 1 MB, it is small. The variety, the type of data, whether it is structured, semi-structured, or unstructured. So the structured data is similar to the table. So Excel is a structured data. Unstructured data is a data without structure. For example, if you go to web or blog or something related to news, so it is unstructured data. Velocity, the speed at which big data is generated. If you use KakaoTalk, okay, so every second there will be message. But if you use only the attendance for this class, so maybe every 1 hour there will be a lot of data. So it is different. Whether the speed is in the second or the speed is minute or in an hour, it is depending on the speed. And there are other three. Veracity, it means the degree to which big data can be trusted. So nowadays there are so many issues where big data, some of the data are not reliable, some of the data are not good in quality. The value, so the business value of the data collected. You can collect many data, but not all data are useful. The variability, so the ways in which the big data can be used and formatted. So there are so many data and you cannot use all the data. Yeah, this is a figure from one research that mentioned that a taxi cab in Beijing, there are 67,000 GPS in a minute. So if the government tries to collect this data, you can see that it's very complex. And how the government can handle the traffic. I think it's similar case in Seoul. It means when the algorithm is complex, you cannot solve the problem in short. You cannot solve the problem in the fast way. So it depends whether your algorithm is constant, no increment time. It means when the data is getting bigger, the running time is still big. So this is it. So when you have 1 GB data, you have 1 TB data, but the algorithm just runs for 1 second. But that is not the case. When the data is getting bigger, usually the operation time also big. When the data is big, the complexity is also big. We call it this is linear, or the operation time increment is. And sometimes your algorithm is in the quadrant. It means the increment is very drastic. The increment is very fast. The operation time increment is quadratic. Most of the time, because we are new on program, we create algorithm which is very complex, which is in the quadratic. So in this class, we will take some ideas how can we reduce the quadratic algorithm into maybe linear, or later we will learn about log linear. So yeah, we will learn many things about this algorithm complexity. And also we need to understand the utility computing. When you run your algorithm in the desktop, it is different with the algorithm in the laptop. It is different with the algorithm in your tablet, and different with your algorithm in the smartphone. So you need to think what is the best solution for its object. And also about the resource efficiency. When you have your algorithm, nowadays people use cloud. Let's say, yeah, I put only bigger, no, three big clouds system. AWS, it is the Amazon, Azure from Microsoft, and this is from Google. And you can see the pricing. AWS pricing per hour is $0.15. For the Azure, the pricing is $0.16. For Google, it is $0.13. And it depends on the purpose. For the general purpose, this is the price. If you are using for the computation, let's say you are using the cloud for your machine learning or artificial intelligence, then yeah, this is the price. If you want to optimize the memory, then it is the price. So you can see Google, yeah, very price. This is based on the price on 2020. So I got the price. And for the accelerated computing, so if you want to speed up the algorithm, then you can use this high relevant PC in cloud, and this is the price. Yeah, of course, you need to consider the price if you're a company. Now you are a student, maybe you don't care about this price. But when you find a job, when you have your own company, you need to think your algorithm. Okay, now, yeah, I think that's the brief introduction about the DSA. Now I'm just going to introduce a little bit about Python, because based on the survey, 50% of you do not attend the Python class. So I don't know which class you attend, or some of you may be the transfer student. I will try to explain Python from the basic one, but because this is not the Python class, not for the basic, so I will speed up a little bit from this lecture. So Python is created by this guy Guido van Rossum, and it was created in the Netherlands. And now Python hosted by the Center for National Research Initiative in US. As you may know, Python is free, open source, and there are a lot of community to support this Python. And this is object-oriented language. Everything is an object. So we will also learn what is the object-oriented in Python. We cannot learn many things during one semester with only 3 months, but hopefully you can have some idea how to improve the algorithm. And there are so many documentation, including the tutorials, the library, and there are many books of Python. Or if you want to learn more tutorials, you can access the python.org. So there are so many tutorials and reference, and there are so many useful resources. So you can find many reference from the Stack Overflow, GitHub, to enrich your knowledge about Python. So on Monday, I already told you, please download the Anaconda. So did you do already? Okay, I hope that you already have your Anaconda. And on Monday, I didn't explain this one. So when you install in your computer, make sure that you do not use Korean character for the installation folder. Okay. So in this case, uh, there are some problems when you install this Python with the Korean character, because in your laptop, you may use your name in Korean and the folder name, for example, C users, let's say your name is Hong Gil-dong, then yeah, this will be written in Korean, then it will cause a problem later. Okay. So make sure that you do not use the Korean letter for this one. Let's say I use this user. So you need to edit the environment variables. And yeah, this is the environment variables. Please put this three folder. Okay, we can see this is lib, scripts, and library. It is inside the Anaconda folder. So let me show you. Okay, system Wangyong Byonsu Kanji. And then you can go to Wangyong Byonsu. And then there is pet. Okay. So in this case, I guess the computer, yeah, this computer already have the Python and they only refer to the script. Okay. So they install in this folder. Yeah, I do not know who installed in this computer. This is the computer from the school. So they install in this folder. It is too long. So they call the folder scripts. I hope there will be no issue. But I recommend you to put more folders. Here I put the lib and library. Why do we need to put this folder? Because later on, if you need more library, so the library will be saved directly to this folder. And if you put this path into your system, then you can automatically read the library. So please make sure this one in your path. Okay, make sure that you put in your Google. For this computer, I will leave it as it is. If there is any problem, I will fix this one. But in your computer, please put these three folders. So if you already installed your Python, make sure that your Python and Conda works well. The way to check whether the Python and Conda works well, so you can go to command prompt and then type Python. There will be no error if Python installed correctly. So let's see. You can go to command prompt. Okay, maybe. Okay, I think in Korean it mentioned prompter. Or if you already installed your Anaconda, then you can see the Anaconda prompt. Okay, so you can see Anaconda prompt. So two things, you can use Anaconda prompt or you can use your prompt. Let me use Anaconda prompt. So this is the prompt. And if you already install and if it is working perfectly, you can type Python. And once you enter, you can see there is a Python working. What is the question of your Python? So you can try print hello. Then if it is working well, then your Python is already good for the next. Okay. Okay, let me check whether you already have your Python or not.